This is an example of how to find the shaded region, the area of the shaded region. We start with the beginning here. We have y equal x minus 4, which is the equation of the line that's given to us, and y equal x squared minus 4x, which is the equation of the parabola drawn. So you're lucky you have the drawing in front of you, and you can see there's an intersection at a point 4, 0, and at a point A. We are asked here to find the coordinates of point A. First of all, to find the coordinates of a point of an intersection between two lines or a line and a curve, the y values, they should be equal. So we will have to put the x minus 4 equal to x squared minus 4x and solve, as you will see in this slide. By the way, this is an example from past HUC paper 2013. Okay, now as we said, we gotta put the y values equal, so therefore we'll end up with x minus 4 equal to x squared minus 4x. Solving this, putting collecting like term, we will end up with x squared minus 5x plus 4 equal 0, which will be easy to actually factorize as we previously discussed. X on this side, x on this side, two numbers multiplied together to give me 4, at the same time add them to give you minus 5, and the only ones would be minus 1 minus 4 equal to 0. Of course, solving this, we will have x equal to 1 and x equal to 4. We already have x equal to 4 on the diagram, which is substituting, which is the point 4, 0, and we're after the other point of intersection, which is point A. Now we are given x to be the value of x coordinates equal to 1. Substitute that in one of the previous equations and you will end up with y equal to minus 3. Therefore, the coordinates of A, 1 minus 3. And that will answer our first part of the question. The second part is finding the area of the shaded region. Of course, the coordinates that we found of A and the other points will help us in being able to integrate and find the area of the shaded region, and they will be actually the limits. So in this case, our shaded region is bounded from 1 to 4. And of course will be the top graph minus the lower graph. Dx. This is how we'll do it. In our diagram, you notice that the top graph is the graph of the line, which is x minus 4, and then we'll minus the bottom graph, which is the parabola. And don't forget, put the two brackets and then dx. Okay, we can expand all this, and we should end up with x minus 4 minus x squared. Don't forget the signs here will change, plus 4x dx. Again, from 1 to 4, you will end up with minus x squared plus 5x minus 4 dx. Okay, continuing integration, and we will end up with, use the square brackets in this case, you will end up with minus x cubed over 3. It's the normal way of integrating. 5x squared over 2 minus 4x, and the limits from 1 to 4. The next step is, of course, substituting 4 first instead of x, and then minus substituting the 1 in, and we will end up with minus 4x cubed over 3. This is where students normally make mistakes, so take it easy when you are substituting. And that's a 4 squared over 2 minus 4 times 4 minus, put a bracket here, then substitute, and you have minus 1 over 3 plus 5 over 2 minus 4 bracket. Putting all this on the calculator, you will end up with a 2 and 2/3 minus plus 11 over 6. And the calculator will give you 9 over 2, which is, of course, it's a 4.5. And since we're finding area, will be square units. And this question was worth 5 marks. 2 marks for the first part, 3 marks for the second part, and it's pretty straightforward. Thank you.